This method can help address an important challenge in combining microscopy with microfluidics by enabling refractive index matching between the microchannel structure and aqueous media inside the channel. The main advantage of this technique is that it is compatible with fabrication methods commonly used to create microfluidic devices.
Another key advantage of our approach is the method used for sealing microchannels made of materials with low adhesion, which is a common problem among low refractive index polymers.
Visual demonstration of this method is crucial as the steps to seal the channel can be difficult to get right. For example, it is important that reservoirs are unobstructed during clamping.
Begin this procedure with fabrication of polydimethylsiloxane, or PDMS, negative, as described in the text protocol. Then, fill the PDMS negative with 400 microliters of My133 V2000. The negative must be slightly overfilled. Place the My133 V2000 filled PDMS negative into the vacuum chamber for 2 hours to remove any bubbles. After removing the My133 V2000 from the vacuum chamber, press a glass slide against the top of the slightly overfilled negative to create a flat surface of My133 V2000 and to prevent oxygen from inhibiting polymerization. Next, insert the My133 V2000 into a 400 watt UV oven. Set the UV radiation to 50% of the maximum intensity for 300 seconds to cure the microchannel. This is a power of approximately 4.5 joules per square centimeter, roughly double the minimum